Okay, it's time for things to get real. Ice cream is causing drowning. Let's have a look. Here's a chart that shows ice cream sales against drownings in swimming pools. If you plot the data from different months of the year, you get a very strong pattern. Can you see that pattern? As ice cream sales increases, more drownings happen. So one of our favourite treasured snacks, there you go, there's a terrible drawing for you, is causing drowning. So it's very simple. We're going to have to ban ice cream. This is exactly the kind of useless information that we talked about previously. In part 1 of this section, I made a true but ridiculous claim that 99.9% of Swedish people had an above average number of legs. Now I'm telling you that ice cream results in drownings and that we should ban ice cream. But it's true. It's 100% true. So what are you going to do? Shall we ban ice creams? Let's look at another one. Number of Alexas in the world. And obesity rates among children. So Alexa, the device where you can get it to play music. Over time, we've seen an increase in Alexas, we've seen an increase in obesity. Therefore, Alexa makes you fat. Now, if you sit back and if you allow people to use very simplistic statistics to convince you of things, you are going to be in for a rough ride. Now, we've seen a lot of this in the recent debates. This is 2018. Brexit has hit the UK in an amazing fashion. I'm not going to talk to you about Brexit because I'm not here to talk politics and I'm not fully equipped to answer all the nuances. But, like all things, if an argument sounds simple, it's probably not true. Cast your mind back again to part 2 of this, the layers of the onion. The 2 cricket players who were so dramatically different. So many extra factors to consider. It's well worth rewatching that if you need to. This is not as simple as just saying, well, hang on. You've shown a link here. You've shown a clear relationship. Alexa makes you fat. We should ban ice cream. Okay? Now, what I'm trying to introduce to you here is a really important statistical technique for representing data. Okay? What I'm introducing to you here is a scatter diagram. But scatter diagrams are dangerous, like all data. So you have to look at the hidden things behind it. So, let's take a look at a scatter diagram and work through a task. A scatter diagram uses a chart with two axes, and we're going to look now at an example with weight and height. And it allows you to compare things, in this case people, on two different variables. Now, comparing two variables is good because you can say, as this one changes, what happens here? For those of you listening carefully, I said changes. I didn't say, as this one changes, what does this one do to this one? And we'll talk more about that shortly. So, let's look at some examples. Let's look at the average man in the UK. So his weight is going to be something like 13 stone, and his height is going to be something like 5'11". If you don't like stone, that's about 80 kilograms. And that is a UK male. Now, where would you plot a sumo? Well, he's going to be a lot heavier, isn't he? And weight is along this axis, so we're going to go this way. How tall is a sumo? I'm going to come this way, but he's also a little bit taller than the UK average male. So I'm going to come straight across this way, which is to make him heavier, and then come up a little bit. Okay. Now, hopefully some of you have seen Charlie and the Chocolate Factory. Because now I'm going to talk about an Oompa Loompa. Not very tall, not very heavy. So I'm coming down here. I'm going to put my Oompa Loompa here. And you can already see there's a bit of a pattern emerging here. Let's take a rugby player next. Let's take Johnny Wilkinson, was a very famous player. He was about just over 6 foot, and he was about 16 stone. So he's going to be heavier than the UK male and a bit taller. Okay, let's take Lionel Messi. He's shorter than the average, so I'm coming down, and he's a bit lighter. You'll notice that I'm only here doing men. And that's because I'm trying to keep something the same so that I don't get distorted information. Let's look at the world's tallest man. Now he's actually only about 17 stone, so he's about here. But his height is up here. So most of our data is fitting a pattern, but some are not. And what happens as you build up more and more people is you start to see sometimes, and each crosses another person, you start to see a pattern. Now within our pattern here, I'm going to circle these 4 because this data seems to have some kind of clear link. And you would probably have said to me that as people get taller, they get heavier. So you'd expect as weight increases, you'd expect height to increase. Now tell me something. What's the word we use for these four out here? And we've used it previously. The word we use is an outlier. So this person here is very tall compared to how heavy we'd expect them to be. This person, I'm afraid, is quite short but quite heavy. And the same here. But you can see the scatter graph gives you a general pattern of behaviour. And in fact, you can plot lots of graphs and you can see different kinds of behaviour. Here you can see something increasing and something decreasing. Here you can see something decreasing and then increasing afterwards. And we'll talk about these examples in the next video. But a scatter graph, essentially two variables plotted and then looking for some kind of relationship. But remember what we said at the start. We're not going to ban ice cream. Alexa doesn't make you fat. The information that's presented doesn't tell you everything. So we've got to dig into it and find out what's really going on. We'll do that in the next part.